Hi, my name is Sami Mujawar and I work for ARM. Today I'll be talking about the dynamic tables framework, which is a step towards automatic generation of ACPI and SM bias tables. We'll have a brief introduction followed by a dynamic tables framework. Then we'll have a look at the status and plans. Then I've got links to where you can download the dynamic tables framework from, and we have time for questions. Let's have a look at the brief background to understand the motivation behind developing the dynamic tables framework. We realized we had a number of firmware builds for a platform. Let's take, for example, the ARM Juno development platform. We had 3 different configurations that we wanted to test, which was big, the big little, and the little. For this, we had 3 MADT tables. Then we had the options for display and headless, for which we have 2 FADT tables. Then we have the debug and release builds, and we end up with having 12 firmware binaries with 6 ACPI variants. We also found that we've got multiple firmware builds for very similar looking platforms. For example, the ARM FVP models, the base platform mostly remains the same. What changes is the addition of new IP and the base addresses for certain peripherals. We also found that generating tables by hand is prone to errors, and we end up spending a lot of time debugging. This made us think if we can find a solution to address these issues. So these are some of the goals for developing the dynamic tables framework. So we wanted to have configurable firmware builds, we wanted to unify the firmware builds, we wanted to minimize and eliminate the human-induced errors, and we wanted the ability to generate firmware that complies with the relevant specifications. Not only this, we also wanted simplicity. Say, for example, we wanted to have to install ACPI tables. All we need to do is provide the hardware information, and the framework should generate the ACPI tables for you. We also wanted to use pre-generated tables. Let's have a look at the dynamic tables framework. So here is the diagram of the architecture. To the right hand side, the orange blocks are the platform specific modules, while to the left, we've got all the standard and generic implementation. So mostly for a platform, you would typically implement the configuration manager. One of the main responsibilities of this configuration manager is to probe the hardware and get the required hardware information, or collect the hardware information using some other techniques. And it will then populate a platform information repository, which has got a full database of all the hardware information. The table manager is a top level component which drives the table generation and installation process. So it's responsible for probing the table factories to get the required generators and installing the tables. The table generators, for each table, you will have a table generator. The table generator implement the platform specific, implement the logic specific for constructing a table, and they will use the configuration manager protocol interface to fetch information about the hardware. It will also perform checks to see whether the information that is provided is matching with the relevant specifications. Then we have 2 types of table generators, standard table generators. The standard table generators implement the logic for implementing a table for a particular architecture, while we've also got OEM tables which allow you for customizing the table customizing the tables. Here's the table generation sequence diagram. So you can see the different components that interact to generate a table over here. So you can see the table manager will query the configuration manager using the configuration manager protocol to get the list of tables to install. Then it will go and get the required generator for generating the tables. And the table generator will then again use the configuration manager protocol to get the required hardware information for generating a table. For example, if it's a MADT table for an ARM architecture, then it will go and get the information from the configuration manager about the gig distributor, and it will construct this table. And then once the table is constructed, it will then use the ACPI table protocol interface to install the table. let's have a look at the current status. So we prototyped this implementation on Juno and FVP models, and we have got support for ACPI 6.2 tables, which will be listed over here. We plan to add more support for ACPI tables, and we also plan to implement hardware information parser, and we are also looking forward to install adding support for SM bias tables. The hardware information parser is a module that is capable of parsing a hardware description file. So SoC design tool could emit a XML or JSON file which has got information about the entire hardware on the platform, and the hardware information parser will consume this information and populate the platform information repository, which can be used later for generating the tables. Yeah, I've got links for where you can download the dynamic tables framework. Questions? Any?
Just out of curiosity, I came late, but what's the patch for?
Oh, the patch is basically just yeah, the ACPI patch, which is there. Yeah, so what we've got is for the for the DSDT tables, the ASL files, the technique that we use to add them to install them is basically we convert the ASL files into a binary blob, and the ASL compiler currently supports doing that, but you can't use it in C file. So what it does is basically you get an array which has the binary blob of the table data, but all the tables that if you want to generate multiple tables, all of them will have the same name for the C array that is generated. So this patch just solves the problem by creating a unique array name.
So this is a compile time change.
So this is a compile time change, yes.
Which compiler are you supporting?
I beg your pardon?
Which ASL compiler are you supporting with this?
So this is the IASL compiler, the Intel IASL compiler.
Okay. And what did you change in ACPI view, just out of curiosity?
Oh, that is another tool which allows you to examine the contents of the ACPI tables from the UEFI shell. So not only you can just not only you can examine, but you can also view. It can also do some consistency checking, and it will report if it finds some errors in the tables as well.
Okay, so you're just using it as is.
Yeah. So what you could do is you could so if you want, you can generate the firmware using the dynamic table framework, and use the ACPI view tool to dump the table. So it also has an option to dump the table output as a binary blob. And what you could do is later on you can say that, okay, I have now got a table which was generated using the automatic framework, and you can just use the binary blob to install it next time.
Okay, thank you.
So that allows you for doing some optimizations if you want. Yeah.
So the format that you're reading from, this means that you're not initially generating ASL or SM bias tables. When you construct the platform, you're putting in an intermediate format, and then the runtime decision is used to take that out of the configuration and turn it into the corresponding tables.
Yeah, so for some of the tables, like for example the MADT or the GTDT and other tables that we have, you would construct them purely based on the hardware information that is provided from the configuration manager. For the ASL tables, what we intend to do is we'll use a template, and we'll compile the template using the IASL compiler and generate this binary blob output which is there, and then you can use that template for for example, if you have a UART that you describe using the ASL tables, you can generate the binary blob and keep it ready as a template, and then on the fly you can patch the base addresses and the interrupts and other stuff using the dynamic tables framework.
Okay. And since you're doing this at boot time, or table construction, is there an impact on the boot speed?
Yeah, there will be an impact on the boot speed. We haven't measured as such what is the impact, but I don't think it's going to be a significant impact.
Okay. So you don't have any metrics of like it increases
No, we
by a
don't have
certain
any
number
metrics.
of seconds. Okay.
No, no.
All right. Any other questions?
Might as well, since I'm the only one that has questions. So this configuration database, this XML, JSON stuff, are you using that both to set configuration stuff for the C code, for PI and Dixie and stuff, and for the ASL stuff? Or how do you keep those guys in sync?
So right now, as I said, this is a prototype implementation as a proof of concept. We haven't implemented the module which can parse the hardware information from an XML or JSON file as yet. Okay. So we're still planning on and thinking about how we can actually do that.
So are you planning to make it so you can use that same data across the whole scheme of things, or do you have a methodology in mind at this point?
No, our understanding was that we would first use it for the dynamic table generation part at the moment.
Thank you.
All right. Any other questions? Okay, one up here. We'll sneak under the camera.
Not really a question, just a consideration on the ACPI view. So maybe you can just point out a bit better that the ACPI view is a completely independent tool with respect to the dynamic tables, and it can be used independently even with a static table description. So you can run the ACPI view script from your UEFI shell to verify your table description that are also statically defined if you want.
Yep.
If you want to clarify that point, Sami.
Yeah, so the reason we developed this tool was we wanted a tool in the shell with which we can just examine the ACPI table that are installed. So we've got this tool which actually parses the ACPI tables and dumps the information on the UEFI shell. And we've also added flexibility to add consistency checking. So if some parameters are not right, it would just flag them up, and you can get this information on the UEFI shell itself. So this particularly is useful if you are trying to boot an OS and the OS does not boot. Then you can use this tool to examine the table contents.
Any other questions? Okay, we'll go and wrap this one up a little bit early. Thank you very much.
Okay. Thank you.